In this lesson, we're going to go through transformations on trig functions. In the previous lesson, we talked about vertical stretches and horizontal stretches, as well as reflections. And in this lesson, we're going to add on the horizontal and vertical shifts, so left, right, up, and down. Just like in our previous unit, we can put all of these transformations together using this format. So you'll see here we've got A, B, H, and K. So remember that A is your vertical stretch and reflection. B is horizontal stretch and reflection. And then we have H, which is our horizontal shift. So left, right. And K, which is our vertical shift. So up, down. So those are our four values and their corresponding transformations. Now remember, in the previous lesson, we talked about how the period is equal to 2 pi divided by the absolute value of B, and the amplitude is equal to the absolute value of A. Now what's also helpful when we start putting all these transformations together is to also look at something we would call a median line or a sinusoidal axis. What this line basically is it's the line that divides the wave in half horizontally. So, or I should say in half, the line is horizontal, and it divides it equally. So for example, if we had a wave like this, that's not exactly even, but it would be the line that goes right through the middle of it. We can also calculate the minimum and maximum, and all of these relate to K. So you'll notice K is the vertical shift up and down. The median line as well as the minimum and maximum are going to move up and down with that K value. And then we also have the horizontal shift or the phase shift, which comes from H. This tells us how much left or right we're moving. So really important when you're doing these transformations. With trig functions, it can get a little bit confusing because there's a lot going on. So I've laid out some steps for you to follow. As with most things, there's lots of different ways to tackle these kinds of problems, but what I found is this series of steps really organizes things and makes it a little bit easier to follow through all the different things you need to consider. So first step, always find the period and the amplitude. We did lots of this in the first lesson. Calculate those values. Now the things that we're going to add on is the idea of this shift up or down. So you'll notice that this first step, this deals with your A values and your B values. Next, we're going to look at the K values. So the next two things deal with the K value. The median line of the graph will be at the K value. So if you have a K value of 2, let's say, that means a shift up by 2. Your median line will go from being right on the axis, the x-axis or theta axis, and it'll move up 2. So the whole graph will move with it. You can also then use the amplitude and that midline to draw some boundaries at the maximum and the minimum. So you're going to find the minimum and the maximum. When I do some examples, this will all come together. So these things here all deal with the K value. Okay, then you're going to start, so this is when you start putting things on the graph. So on your graph, you're going to have a dotted line at the midline. You're going to have dotted lines at the minimum and the maximum. And then you're going to put your period value on the 4th tick mark. So splitting your graph into 4 sections is really helpful, and the period is always going to go on the 4th section. It means you're going to draw one full wave and sort of divide that wave into 4 parts. At this point, I would recommend lightly sketching the curve as you have it so far. So use your midline, use your min and max and the period to sort of lightly draw your sine or cosine wave. After you've drawn it, then you're going to go ahead and do any reflections and also shift the graph left or right. You always want to do these two steps last because you need your graph to be stretched as well as moved up or down, all of that kind of stuff to happen first. So make sure you do these reflections and shifts left or right at the end. So I'm going to show you how to do one because, like I said, it's a lot easier to sort of put these pieces together when you're actually working with an example. So in example 1, you'll see here we have an A value of 1/2 and a B value of 4. So that means our amplitude is 1/2 and our B value is 4. That means the period is 2 pi over 4 or pi by 2. Now in this function, we don't have a k value. There's nothing being added onto the end here. So that means your sinusoidal axis is right on the axis. This question is actually very similar to what we did in the last lesson. So this graph is not moving up or down. The minimum for this graph is going to be at -1/2, and the max will be at 1/2 because that's our amplitude, and this also has no shift. So this is a good review from our first lesson. So when I'm putting all of this together, you can draw yourself a minimum and a maximum if you want to. So for these ones, this one's pretty straightforward. Your midline is there. If you wanted to draw yourself a dotted line at the top, you can, and at the bottom. When you're working on something that's on grid paper, you may not need this. Okay, so this is at 1/2 and -1/2, and our period is pi by 2. So I'm going to make 4 tick marks. And I'm going to show you 2 full cycles. So on the 4th tick mark, I'll mark the period, pi by 2. Over here is -pi by 2. Now that I have all this information, I can go ahead and sketch. So I've got the sine graph, meaning I'm starting at the middle, going up to the top, to the middle, down to the minimum, and back to the middle. So this wave is going to look like this. And same thing on the other side. So down and then up to the middle and to the bottom. Oops, I skipped a step there. Sorry. Thought that looked a little bit funny. For some reason I skipped the middle. There we go. Maximum, minimum. There we go. So there is our graph. The arrows on the end. So that one's not too bad. Kind of a review of the first lesson. If we look at the next one, we've got cosine of pi x and +2. So here our A value is just 1, meaning our amplitude is 1. Our B value, so this is B, is pi, so 2 pi over B, or 2 pi over pi, so the period is just 2. And then this +2 is not in the brackets, so that's a k value. So that means the sinusoidal axis, the middle of this graph, is going to be at 2. So I'm actually going to draw that first. So 1, 2. So the middle is going to be at 2. So this is the midline of this graph. what that means is that this graph is going to oscillate above and below that midline, and the amplitude is 1. So that means that the maximum will go up to 1, and the minimum, will go up to 3, and the minimum will go down to 1. So your minimum is 1 and your max is 3. It's just the sinusoidal axis minus the amplitude and the sinusoidal axis plus the amplitude. And again, this one has no shift. So now that I have all of this set up, I also need to set up the period. So 1, 2, 3, 4. 1, 2, 3, 4. So I'm going to go from -2 to 2. Now sometimes in the question it will state how much of the graph it wants you to show. This one doesn't state how much of the graph you need to show, so you can use your judgment. Now I'm going to be graphing cosine. So what you want to do is you need to treat this midline how we've been treating the axis. So the cosine graph starts at the maximum, so that means it starts up here. Then, after 1/4 of the way through, it's at the middle. At the halfway point, it's at the minimum. 3/4 of the way through, it's back to the middle. And then at 1 full period, we're back to the top. So that's the cosine graph. So you're treating those 3. This is why those markers, these dotted lines, are really helpful, because then you can just use the pattern of the graph and sketch it in. So here we're at the top, down to the middle, to the minimum, to the middle, and to the maximum. So we've just got another period of this cosine graph with arrows on both ends. So that is the graph of cos pi x plus 2. If we go to question C, we've got 2 sine x plus pi by 4. So what can be really helpful too is when you start is just labeling what these are. So this 2 is an A value since it's right in front. This is an H value, and there's no B value or K value. So what this means is our amplitude is 2. The period, there's no B value, so the period is just 2 pi. And then your K value is 0. This is not shifting up or down at all. So what this means is your minimum will just be -2, and your max will be 2, because your midline is not moving up or down. So you just have to add your amplitude of 2 and subtract your amplitude of 2. Now once you have this, you're going to want to put some of this onto your graph. So we have a maximum of 2. Like I said, these dotted lines are technically optional. They're not part of the graph, they're just there to be sort of a marker for you to help you sketch in the graph. So they're not to be confused with asymptotes. Okay, so we're going from 2 to -2, or -2 to 2. Our period is 2 pi, so 1, 2, 3, 4. 1, 2, 3, 4. So there's sort of our baseline. We can now graph lightly. I'm going to graph sine. So I do that before I deal with the shift. So I'm going to save the shift. I would also save any reflection for after. So I'm going to graph this. Sine starts in the middle, goes up to the top, to the middle, to the bottom, to the middle. So lightly I'll just sketch this in. And then to the bottom, middle, top, middle. You'll see why sketching this in so far is helpful, because when we go to do the shift, we now sort of have a graph to work with, and we can then just shift this graph either left or right. So this so far is the graph of 2 sine x. I need the graph of 2 sine x plus pi by 4. I know that horizontal movements always do the opposite of what they look like. So that means that this graph is shifting to the left, pi by 4. Now, if you look over at my scale, you'll see this is 2 pi. That means this here is pi, and this is pi by 2. And this is 3 pi by 2. So if I want to move this pi by 4, I need to figure out how far that distance is. How large is pi by 2? And what you'll notice is that this is, how large is pi by 4? This is pi by 2. So 1 tick mark is pi by 2. Pi by 4 would be half of that. So what I can do to my scale now is I can actually add in a pi by 4. So this is why it's helpful. So I'm going to divide all of these in 2. This is why it's helpful to start by sketching this graph and do that shift after, because having a baseline graph to work with is really helpful, and then going and doing the shift, because you'll see here this gets really messy really quickly. So if I just add in all these little halfway fourths, I can then go ahead and draw. I'm going to use a different color so you can see it. Basically, I'm going to take every single point that I have, and I'm just going to move it over to the left, not the right. I'm going to move it over pi by 4. So this one would kind of go off of what I have here. This one, I'm going to move 1 tick mark to the left. This one, 1 tick mark to the left. Same for all of my points. This one over, this one over, over, and you can see that when you connect those dots, you'll see that your graph, you can tell that it's just been moved over slightly to the left. So this would be the final graph. And it's helpful if you label it with the equation. So you can see there I've got 2 versions of that graph. The first one without the shift, and then the final one includes the shift. For question D, we're going to do the same thing. So for question D, first, if you want to start by labeling everything, you've got an A value. Now, one thing to note, and hopefully you remember this from the last, or when we learned transformations, is that this B value needs to be factored out. So just below, I'm going to factor out that B value. So I'm going to factor out the 2, which means this becomes pi over 2 plus 1. So, actually just going to write this below. I have an A value of 2, B value of 2, a shift to the right by pi by 2, and a shift up 1. So I'm going to start by finding the amplitude and the period. So the amplitude here is 2. The period is 2 pi over 2, which is just pi. And then that also allows me, well, actually I've got those 2. So now I'm going to find my midline. So my midline, remember, would be at 1. So K is at 1. That's the midline, which allows me to find my minimum and maximum. So remember, my minimum is the midline minus the amplitude, so -1, and the maximum is the midline plus the amplitude, so 3. Now I can go over to my graph and sketch that information in so far. So my midline is at 1. That's at 1. My maximum is at 3, and the minimum is at -1. Just do your best with the scale when you don't have a grid to work with. -1. The period is pi, so 1, 2, 3, 4. 1, 2, 3, 4. So that's what I know so far. So I've dealt with the k value, which is the midline. I've dealt with the b value, the period, and I've dealt with the a value, which is this amplitude. So I'm going to sketch this so far, and it's a sine graph, so I know I'm starting at the middle, going up to the maximum, down to the middle, to the minimum, and to the middle. So here's my 1/2 of my sine graph, or I should say 1 period of the sine graph. So there's that. Do the same on the other side. Be really careful. I see lots of people who will accidentally still draw points on their axis, but remember that midline has moved up. Up, down. And then the last thing that I'm going to do is I'm just going to shift this pi by 2, but to the right. So the key thing is figuring out where is pi by 2. So you'll see here that the 4th tick mark was pi. That means that halfway, we're at the 2nd tick mark, this is pi by 2. So that means you're going to take each point and you're going to move it to the right by 2 increments. So I'm going to start over here. I'm going to take this point and move it 1, 2. I'm going to take this point and move it 1, 2. This little middle point is hard to see because I've covered it with a new one, but it's going to go over 1, 2. So you can see sort of this sine curve starting to form. I've got to move this one over, 1, 2. And once you have a few points, you can then sort of see the shape. Here is going to move over. This one's going to move over. So you can see here that this graph is going to go up and then down. So essentially what's happening is this actually looks a lot like a reflection. It's not a reflection. It's just that sometimes with these sinusoidal graphs, transformations can look the same as other transformations. So that red graph is the final graph of 2 sine 2x minus pi plus 1. And then finally, we've got one more example here. In this graph, we have an a value of -1/2, a b value of 1/3, and a k value of -2. Remember, if there was an h value, it would be in brackets with the x. So in this case, my amplitude is 1/2. The period is 2 pi divided by 1/3, which is 2 pi times 3/1, so 6 pi. The midline here is -2. And then your minimum is -2 minus the amplitude, so -2.5. And your maximum is your midline plus your amplitude, so +0.5, so -1.5. So you'll see here that I've dealt with the amplitude, I've dealt with the period, and with K. The only thing I'm missing is the reflection. So I'm going to save that reflection for the end. I should say this is a vertical reflection. So I'm going to go over to my grid, and I'm going to just put in what I know so far. So 1.5, -2. Again, where you place these is sort of tricky when you don't have a grid to work with, so just do your best to estimate. So there's my guidelines. Make sure you label them. So I'm going to label this -1.5, -2, -2.5. And then I'm going to draw 4 tick marks, again on your axis. You don't want to draw on this midline because you don't want to be labeling your axis when it's just supposed to be a guideline. So here, your period is 6 pi. 6 pi. And then cosine starts at the top, goes to the middle, goes to the bottom. Middle, top. So here you've got your bowl. Again, I like to sketch this in first and then go back and do the reflection. Obviously, if you wanted to do the reflection right away, you can. There's nothing stopping you. I just find that this makes it a little bit easier, and I see students make less errors when they do this sort of guideline to start with. So that's your graph so far with everything except the reflection. And then the last thing you need to do is just put in the reflection. So what this reflection means is you're reflecting vertically. You're reflecting this graph vertically over the midline. So if it's above, it's going to come down below. If the point is on the midline, it stays on the midline. So it's just going to mirror over that midline. So you can see here, it just looks like that. And then it's going to come up, mirror. So you're reflecting vertically over the midline, not over the x-axis. So that would be your graph. These graphs take a lot of practice, so make sure that you try quite a few, draw them out, draw as many steps as you need, and let me know if you have any questions.